Just looking at a few harder simultaneous equations. So I've got two equations here, equation 1 and equation 2. And because you've got your x's and y's on the same side and your numbers on the right, you may think that you could use elimination method for this particular one. However, substitution would be easier because see this x, so I've got 3x minus 5y is 28. It's too hard to get x or y on its own there, but here I've just got x plus 4y equals 15. If I just rearrange the second equation, I could use substitution. So I'm going to put rearranging equation 2. I can just, the inverse operation of plus 4y is minus 4y. So I can rearrange equation 2 to make it x equals 15, take away 4y. I'm just going to call that equation 2a because it's like equation 2. I've just rearranged equation 2 and I'll call it equation 2a. So now what I want to use, I'm not going to use equation 2, I'm going to use equation 2a and equation 1. So now I can just substitute equation 2a into equation 1. So I start writing out equation 1, I've got 3, and now I substitute for the x, and the x is 15 take away 4y, so coming back up to equation 1. 3 times x, which is 3 times 15 take away 4y, then I keep going. Take away 5y is 28. And now I can just expand and solve this. I've got 45 minus 12y minus 5y equals 28. Minus 12y minus 5y, that's minus 17y equals 28. Inverse operation of plus 45 is minus 45. So I've got negative 17y equals 28 take away 45 is negative 17. And now I need to divide by negative 17. So y is negative 17 divided by negative 17, which is 1. Now I need to find out what x is, so I'm going to substitute y equals 1. I think it would be easier into equation 2a. So I'm going to substitute y equals 1 into equation 2a. So that gives me x equals 15 take away 4 times 1. So x is 11. So therefore my solution is x equals 11 and y equals 1. So this is a slightly harder example of solving simultaneous equations using substitution. Okay, and we can see that we could substitute because this x is sort of on its own. If we rearrange it, we do have x on its own and it's easy to substitute. All right, we're going to look at a harder elimination method type of question. Harder elimination method type of solving simultaneous equations. It's not, the syllabus does not specify that you need to do this, but it's just best that I show you one so that if you ever did see one, you would know what to do. You would never use substitution for this question. Do you know why? Can you see an x on its own or a y on its own that can be rearranged? And look, you can't at the moment use elimination either, but we can choose, for example, to make these y's the same. So if you look at 2y and 3y, what's a common number between like 2 and 3? You can make both those numbers into a 6. So what I'm going to do, this is my aim, I'm going to make a common term of 6y. Now, I've got equation 1 and I've got equation 2. What I can do, if I want to get 6y, I can multiply equation 1 by 3. No, by 3. So I'm going to multiply all of equation 1 by 3. Let's watch. So equation 1 times 3. What's 3 times 3x? What's 3 times 6y? Plus 6y. And what's 3 times 2? 6. So I've taken equation 1, which is there, and I've multiplied everything by 3. So equation 1 multiplied all by 3. So 3 times 3x is 9x. 3 times 2y is 6y. 3 times 2 is 6. Now, I'm going to do something similar with equation 2. If I've decided I want to make a 6y, make 6y common. Do you know what I mean? I'm going to multiply all of equation 2 by 2. So let's go. 2 times 4x is 8x. 2 times 3y is 6y. 2 times 5 is 10. Now, I'm going to rename these equations. Because this came from equation 1, I'm going to call it equation 1a. And because this one came from equation 2, I'm going to call it equation 2a. It means it's equation 2, but, you know, I slightly changed it. Now you can use your method. The syllabus states that this will not be in it. You're meant to only get simple equations like this. However, one of the past papers that you've been given does have a question like this. So now, what are we going to do? So, yes, now that the 6y's, now that I've got two equations where the y's are the same, we can just now use normal elimination. All right, so what I did, I looked at these and I thought, geez, it'd be good if they were both. I can make that easily into 6y, and I can make this 3y easily into a 6y by multiplying the first equation by 3 and the second equation by 2. Notice I write my instructions of what I'm doing on the side. Now I can do my subtraction. So I'm going to do equation 1a minus equation 2a. So what do we get? What's 9x minus 8x? It's x. 6y take away 6y is 0. 6 take away 10 is negative 4. Now I can substitute x equals negative 4 into any equation I want. I wouldn't put it, I'd put it into 1 or 2. Let me put it into 1. So I substitute, sorry, I just had a mistake there and I've just fixed it. So substitute x equals negative 4 into equation 1. So 3 times negative 4 plus 2y equals 2. So I just substituted x is negative 4 into this. 3 times negative 4 plus 2y is 2. So 3 times negative 4, I've got negative 12 plus 2y is 2. So 2y is 2 plus 12, which means 2y is 14. Therefore, y is 14 divided by 2, which is 7. So the solution is x equals 4, y equals 7.